everybody, I'm going to go over how to do a chair flip. That's also going to kind of encompass how we find the more stable conformation for chairs for any kind of cyclohexane situation. So this is going to be what we're starting with. One of the things that we need to practice is making sure that we can transfer from a flat structure of a cyclohexane to the chair conformation of that cyclohexane. So the first thing we want to do before we get started is to number out the cyclohexane. So the important thing to keep in mind here is that it does not matter where you start. It just matters that you're consistent and you're going in the same direction at all times. Okay, so I'm just going to start my numbering here. But again, you can number any direction you want or starting at any carbon that you want. The really only thing that you need to keep in mind is that you number all the cyclohexane. You can number the rest, but I would at least stick 1 through 6 right here. Okay, so our first chair, it doesn't matter which chair you draw, either one works. Okay, so we start up with our chair, and before we do anything on it, I'm actually going to try to do a bigger one here. Just so that I'm not, it's hard to draw the big ones, but it's going to be easier for the video, I think. Okay, so the first thing that we do is we number that chair. Okay, so keep in mind if I went clockwise here, I'm going to make sure that I go clockwise here. And it doesn't actually matter where I start as long as I'm numbering clockwise. Okay, just for easiness though, I'm going to make number 1 over here because to me that just kind of makes sense having them in slightly similar positions. Okay, so 1, 2, 3, 4, 5, 6. Okay, so now that I have my carbons numbered, we're going to go in with our substituents. So on carbon 1, we have an amide, okay, or an amide. So that is going to be dashed here. So that's going to be in the down position. Okay, so we've got down. And keep in mind, if you're not sure about how to do that, I always like to draw on my axial substituent. This is very clearly up, okay? So the nitrogen, and then we've got our amide, okay? So this is down, so this is down, okay? All right, so then on number 3, we've got a tert-butyl group, okay? It's on a wedge, so that's gonna be up. So on number 3, I have these 2 options, okay? I've got an axial and an equatorial. So this is pointing straight up, that's our up. This is slanting down, that's our down. So that means that our tert-butyl group is going to be going up. Okay, and then H is over here. And then 4, we've got OH on a wedge. Okay, so that's going to be up. On carbon 4, I've got 2 places that I can put stuff. This axial one pointing straight down. So the OH must be over here in the up. Okay, so that's all of our options. All of our substituents here. I've got down, up, up. And keep in mind that I go from amide to tert-butyl to OH, amide, tert-butyl, OH. Okay, so everything is the same here. All of the wedge dash information that I have is now put into kind of these axial, equatorial, up, down methods of communicating, I guess. This is just a 3D perspective drawing, basically. Okay, so now that we have the first chair structure, now we go to the chair flip. Okay, I'm gonna scooch this stuff over a touch. Okay, so our chair flip, we're gonna go ahead and start by drawing the other chair. So basically, this one is the footrest to the left. This one's gonna be the flip, which is the headrest to the left. Okay, so we're pulling up carbon 6 and pushing down carbon 3. So 6 is going to be up here now. And then we've got 1, 2, 3, 4, 5. Okay, so again, I'm still numbering clockwise. I've just taken that carbon 6, yanked that up, which is pushing carbons 1 and 5 down. And then carbon 3 is getting pushed down, which is pulling carbons 2 and 4 up. Okay. All right, so now I'm going to go ahead and put in my substituents. So on carbon 1, still have that amide going down. Okay. On number 1, I've got these two options. This one is going up. This one is going down. That's where I want my amide to be. Okay, and then H is over here. Number 3, I've got that tert-butyl going up. Okay, so I've got that option, that option. This axial substituent, we're going down. So that's going to be where our H is, and then tert-butyl group is going up. And then number 4, I've got an OH group going up. Oops, I cheated on that one. So the OH group, I've got the up axial or the down equatorial. So OH is going to be on the axial position. Okay, so that is my chair flip. So these two structures actually require energy to transfer in between them. Okay, but they are the same molecule, but they are just different conformations, as in we just did a simple bond rotation to get from one to the other. So a couple of important notes about this. One thing that we should notice here, so our amide, we started in the equatorial position, and now we're in the axial position. Okay, so very important to note that chair flips do change axial to equatorial and vice versa. Okay, so we do see that change. So we went equatorial over here, axial over here. What didn't change is that we have down here and down here. So chair flips do not change up and down. Okay, so the up and down should never change. If you look at this, that's down, that's down. Tert-butyl is up, tert-butyl is up. OH is up, OH is up. Okay, so those never change. So we still have up, down, up. Okay, up and down don't change, equatorial and axial do change. Okay, and then the final point here is that the big substituents in equatorial positions are more stable. Okay, and I would really recommend building a model for that. Models are just a little bit weird in Zoom, but if you build a model and do a chair flip where you have a big thing like a tert-butyl group axial and then flip it to be equatorial, you'll see how much more room that tert-butyl group has. So that's going to be much more stable. So this chair structure is the most stable conformation. Okay, tert-butyl groups are actually really good anchors where they actually don't want to be in the axial position so much that it will lock this molecule in that conformation, and this just won't even exist. Okay, so that's kind of the main key points about chair flips. So just kind of in summary here, step 1, number your cyclohexane. 2, draw your chair. 3, number your chair. 4, add substituents, according to up and down. Okay, notice that I wasn't really caring at all about where I was putting stuff axial or equatorial. I was just letting the numbers guide me and saying, okay, well, number 1 has 1 here, 1 here. Which one is down? And then I picked that one. It did not have anything to do with axial or equatorial. So we're using up and down from the wedge and the dash. And then 5, draw the chair flip and repeat. Oops. 3 and 4. Okay, so follow those steps, make sure you keep practicing, and let me know if you have any questions.